Hello. Assalamu alaikum. Can you hear me? Hello.
Hello.
Can you hear me?
We can hear you, sir.
Okay. Is the microphone clear to you, or any problem like last time? Clear.
Clear.
Okay. Good. Thank you very much. Okay. Now let's come back to the point. I sent an email just now. Have you got it? Check the email box. Hey, have you seen the email? Okay. This is the actually from last class onward. Actually, this is the scenario.
Yes, sir, I got.
Yes, sir. So it is regarding the class. If you stay every day in the class from the beginning up to the end, I'll take the attendance. And if anybody present from the beginning to the end will get 0.1 bonus marks. All of you will get that one. You can answer the question or not. And on the way in the class, you'll get the, the system. It will be unchanged. So anybody drop, then he will miss the bonus marks, remember. So any problem, anything, emergency number is there, you can contact me, that's it. But I'll verify and then give it. So this is the way we'll go. Yeah, go ahead.
ক্লাস টাইমের ভিতরে কি স্যার আপনাকে কল দিব স্যার? আপনি ক্লাস নিচ্ছেন নাকি পরে স্যার? যদি বাই এনি
Okay, no, you just call me and then immediately you have to talk to me. Okay, what is your problem? If you miss, you miss the point, full stop. So everybody should be careful about it. Don't miss the class. Okay, I think that should be fine. You just stay. I'm going to get a snapshot and then we are going to get it. So I got it. Now we can go ahead. And before starting, just check the screen can be visible and you can hear the sound clearly as well. Okay, now check can you see it?
Yes, sir, we can see.
Okay, now let's come back to the sound system is okay or not. Okay, check.
You can see now, right?
Yes, sir. Now.
All right. Now, the RC circuit.
Okay, like class, can you hear the sound? Did it sound clear?
Yes, sir. Sound is clear, sir.
Let's go and start. Just let you know, like class, today we'll go start the RC circuit and whatever the things we'll teach up to I mean, whatever the things I'll complete today, CT4 will be up to that. So CT4, this Thursday, CT4 syllabus will be from CT3 up to today's class. So RC circuit, whatever the topic I'll finish today, it will be the end of the syllabus CT4. Okay, I hope that should be fine. You can go ahead.
Which is very similar to the RL circuit. And in this case, we'll see the first thing we are going to see today is the natural response. Natural response, if you see the natural response, it is the same way what we have done last time, that there was a capacitor here and a resistor here, and for example a resistor is going to connected to a source. Voltage was developed here, and that voltage we can say as VC voltage. So VC voltage is here as a plus and minus, like that. We are going to give this explanation in this way. Before t is equal to 0, that means t less than 0, it was closed. And if it is closed, then what happened? The current from the battery is flowing through the circuit in this way. The current is dividing into two, IC and IR. And the true current was flowing through the resistor and the capacitor. And what happened when the IC current is flowing through the capacitor, then the capacitor voltage, as I told you, like the water flow into the bucket, the water is accumulating, the pressure of the bucket is increasing, the water pressure. Exactly the same way you should think like this, that when the charge is accumulating in the capacitor due to the current flow, I see the charge is accumulating into the capacitor, and because of the charge Q, V is proportional. I told you, the more the charge accumulating, the voltage across the capacitor is increasing. Remember, I told you like this. Hey, what happened? Can you listen to me what I'm telling? Hello?
Yes, sir.
Yes, sir.
Do you have any question up to this? You please let me know. Main thing here, I want to say the cause and effect. Due to the battery, you connect to the RC circuit, which are in parallel, then the voltage across the capacitor is increasing. Why? Because of what I told you last time, right? The current flow through the capacitor, charge is accumulating. Because of the accumulation of the charge, the voltage of the capacitor increasing, like that. Now you understand? Yes?
Yes, sir.
Now you look carefully. With the voltage developed in the capacitor at time t equal to 0, if someone open the switch, at time t equal to 0, the switch is open. When the switch is open, then the capacitor which accumulated the charge will discharge the all the charge will be discharged from the capacitor through the capacitor current, and the voltage of the capacitor will be decreasing slowly. This is the scenario, and that voltage VC will decrease slowly to 0. Again, the same way, I square R loss, and through that loss it will be decreasing. So in this scenario, the voltage of VC across the capacitor, when the switch is taken off, then it will be a simply free running RC circuit, and the voltage VC in this case will be decreasing slowly to 0. It will be, again, you can see, exponentially decrease the voltage. What we have seen in the last RL circuit, free running RL circuit, it was decreasing, IL was decreasing exponentially. In this case, the VC will be decreasing exponentially, and that equation will come from here, this point. If you apply the KCL, that IR and IC will be adding together, because both are outgoing, you can assume IC and IR. So you can write IC is dVC by dt, and IR is VC by R. VC is the voltage across the resistor as well as the capacitor, because they are in parallel. So if you go with that, then the VC by VC will be minus 1 by RC dt. Now, if you go with that integration, RC is a constant, so you are getting the integration with this, and you are getting here ln of VC and your G to T and equal to minus 1 by RC. Anybody cannot understand anywhere, please stop me and tell me. Okay, this is from here to here, 0 to T. RC is coming from here. Now, again, you have to go with the ln VC to T. So your ln VC to T, here you can go with the 0 to T and equal to minus 1 by RC, and T will be 0 to T. It's T minus 0 you are going to get. So you are getting here ln VC T minus ln VC 0, and this is giving you minus T by RC. And what happened now? Learn VC by, just like last time, you got VC0 and equal to minus E by RC. C. So if you go for,
Okay, live class people, you can hear me. I hope then you can go for question answer session. I'm going to ask anybody randomly. You have to answer. Monirun Nisa, are you there?
Yes, sir.
Can you answer from after this? What will be the next line? VC by VC naught will be equal to here because this is the log, natural log. So what will be this value you think? I'm talking about from here, VC by VC naught. Okay.
Yes, sir.
Will be equal to what? Tell me.
So e to the power minus t divided by RC.
Okay. E for what? E is e to the power. E is what? What is E?
Sir, in the left hand side there is ln and
No, I know that, but E is what? What do you mean by E? E is
exponential.
exponential. Okay. Good. So you are getting this thing. So from here, VCT will be equal to what?
Sir, VCT will be VC into e to the power minus t by RC.
Good. And what about the VC0? Actually, it comes from?
Sir, VC0 will be, sir, when the t will be 0.
Yeah. That is coming from the initial condition. When t equal to 0, this value, we have to get it from there. Good. Thank you very much. I think it should be fine with you. Go.
VC by T by VC0, you are getting here minus e to the power p, because when t is going on, the charge is accumulating, capacitor voltage is developing. But at that moment, if somebody open the switch, at the time when you open the switch, at that moment there should have some voltage across the capacitor terminal, and that will be the initial voltage, and we can assume it is V naught. Like last time we consider I naught, so we can assume this is V naught. So the VC0 VCT will be equal to V naught e to the power minus E by RC. So this is your voltage equation for the capacitor, which is very similar. Last time I'm just writing here, for the inductor we have the equation like this. Can you remember what was the equation? I naught. Anybody can tell me? What of current will be is decreasing in this case. So the of capacitor, it is not current, it is the voltage, because voltage is increasing and voltage is decreasing. Voltage is decreasing in this case, so the resistance I square R loss. The current will be coming out from the capacitor, and the capacitor current will be flowing, and then so the I square R, it will be decreased, but the current will be flowing in the opposite direction. It will be seen later, we'll talk about it. Now, this is what the equation we got for the capacitor voltage. Remember, for RL circuit, it is the inductor current. For capacitor circuit, RC circuit, it is the capacitor voltage, not capacitor current. Capacitor current, you can find it.
Okay, from the class, live class, Mayaz Javier. Mayaz, are you there? Mayaz Javier is absent. Okay, then let's come back here. Kausar Hussain, are you there? Kausar Hussain is absent. Okay, then Sheikh Walid Hassan, are you there? Absent. Then let's go to Rudra Sarkar. Rudra Sarkar, are you there? Rudra Sarkar is absent. Okay. Okay, now let's come here. I hope that Khandakar Labib Junaid, you are absent, right? Labib Junaid. Choiti is absent. He is absent. Okay. Now, Rakimul Islam, are you there?
Yes, sir. Present, sir.
Okay, can you tell me from this equation, if you want to plot VCT dot T is VCT versus T, we have to consider two things. One is the initial value T equal to 0, another one is T equal to infinity. Now
Yes,
at
sir.
T equal to 0, what will be the value for VCT? That means VCT 0 will be what? And T equal to infinity, what will be the value of VCT? Two values actually we are going to find from here. Can you tell me?
Yes, sir.
Go
স্যার
ahead.
ভিসি মানে টি এর ভ্যালু যখন 0 হবে তখন স্যার এখানে যদি 0 বসাই তাহলে স্যার ই টু দি পাওয়ার মানে ই এর ভ্যালু অন হয়ে যায় স্যার। 0 হয়ে স্যার ই টু দি পাওয়ার এর উপরে যাই থাকুক অন হবে স্যার, আর থাকবে শুধু ভি নট। সো স্যার টি এর ভ্যালু 0 হলে স্যার শুধু ভি নট,
Okay,
আর
then
স্যার
next.
ইনফিনিটি হলে স্যার একেবারে সম্পূর্ণ 0 হয়ে যাবে স্যার ভিসি ইনফিনিটি এর মান।
So ultimately, these are the two values you are talking about, right?
ইয়েস স্যার, ইয়েস স্যার।
Okay, good. Thank you.
From the equation,
থ্যাংক ইউ।
from the equation, capacitor current will be coming like this. What is the capacitor current?
Okay, and second question to you, Rakibul Islam.
ইয়েস স্যার, ইয়েস
Then
স্যার।
you get up 0.2. This is VC, right? And if
Yes,
I
sir.
want to find, for example, ICT, what will be the equation?
জি স্যার।
ICT? from
ICT,
VC, yeah, from VC, if you want to find IC.
আইসিটি তাহলে স্যার হবে স্যার আই ভি এর জায়গায় স্যার আই নট ই টু দি পাওয়ার
No, no,
টি
no.
এর জায়গায় হবে
What is
sir?
the relation? Listen, what is the relationship between capacitor and voltage? Capacitor.
আইসিটি, ইয়েস স্যার,
Yeah.
জি স্যার, এটা তো তাহলে হবে স্যার সি ইনটু ডিভিসি ডিভাইডেড ডিটি।
Right. That is the answer you should give me. Okay, good. So
Yes.
you are saying that it will be what? Can you repeat?
সি ইনটু ডিভিসি ডিভাইডেড ডিটি।
Okay, dVc by dt. And
Yes, sir.
what will you do next?
স্যার নেক্সট হবে স্যার স্যার আইসি ইজ ইকুয়াল টু মাইনাস স্যার এখানে
No,
স্যার
what you are going to
ভিসি,
do? VC.
স্যার
right?
ভিসি কে স্যার আমাকে ইন্টিগ্রেট করতে হবে ডিটি এর সাপেক্ষে স্যার। ভিসি এর মান
Easy,
স্যার আমরা এই যে
integrate. Come on, integrate or
সরি না স্যার
differentiate?
ডিফারেন্সিয়েট স্যার
Okay, what is
ডিফারেন্সিয়েশন
the
করতে
VC
হবে
value?
স্যার।
VC?
ভিসি স্যার ভি নট ই টু দি পাওয়ার
Good.
মাইনাস টি ডিভাইডেড আর সি, এটা ই করতে হবে স্যার, তাহলে আসবে মানটা আসবে স্যার এটা স্যার ভিসি ইজ ইকুয়াল টু ভি নট ই টু দি পাওয়ার টি ডিভাইডেড আর সি স্যার।
Ultimately,
ইয়েস স্যার।
what is that? Can you tell me again?
স্যার আলটিমেটলি আসবে ভিসি ইজ ইকুয়াল টু ভি নট ই টু
VC
দি
equal
পাওয়ার
to or IC equal to?
স্যার এটা স্যার ওয়েট স্যার এক সেকেন্ড স্যার আইসি স্যার আইসি এর জায়গায় তো স্যার আমরা ই বসাচ্ছি স্যার ই টু দি পাওয়ার, ও সরি স্যার গিভ মি অন স্যার অন চান্স। আইসি ইজ ইকুয়াল টু স্যার এই মানটা বসালে মাইনাস ভি নট ডিভাইডেড আর ইনটু ই টু দি পাওয়ার মাইনাস টি ডিভাইডেড আর সি।
So finally, what is the answer? IC
স্যার
equal to?
আইসি ইজ ইকুয়াল টু মাইনাস ভি নট ডিভাইডেড আর
V naught divided by R.
into exponential to the power minus t divided rc.
Good. T divided by RC.
rc.
So this is what you can get the IC
Get it.
current equal to, right? Good.
Yes, sir.
And these are the things. Thank you very much. You get 0.1. Okay, good.
Current, if I say IC equal to what? If you want, hey, what is that? IC equal to, remember, dVc by dt is the equation, right? Capacitor current equation.
Yes, sir.
So your VC you substitute here, and then you can get it. What is that thing coming? You can easily find it from there, and you can easily. So that is your IC you can get. This will be the IC equation you should get from that. You find the VC and draw the graph, and from there you find the IC. For the equation, IC equal to C dVc by dt. Last time you found the VL from LDI by dt. Now, in case of RC circuit, you find the other way around actually. Everything is other way around. You have to find the IC from the equation C dVc by dt. Jawatan, have you sent your VL? Let's see. It is 0. So exponentially it is dying. Exactly the same thing what happened. So VC in this case will be equal to, the equation is equal to V2 of e to the power minus t by RC. So this is what the voltage. And as I told you, you have to find it from here. IC equal to, already we found. I'm just going to show once again. but I'm not going to show you details. If you do it in this way, you get T by R. Good. And
Tanima Abbas, are you there?
Yes, sir.
Okay, can you answer to this question? From this equation, I see, as Arqibul Islam said, this is the IC equation we can derive from the VC. And in this IC equation, if you put t equal to 0, because we are going to draw the IC curve. So at time t equal to 0, t equal to infinity. For t equal to 0, what will be the IC value from here, from this equation?
Sir, I see t equal to 0, it will be minus V naught by R.
Minus V naught
And
by
the
R.
infinity is equal to, and the infinite, I see infinity is equal to 0.
0. Okay, good. Now if you can plot it, then you can
0.
see the curve.
So from my, what is the
The
equation
curve
for
is
this?
like that, right? Minus V at time t equal to 0 minus V naught by R, and t equal to infinity is 0. So the curve is coming like that. Tanim Abbas, you understand it?
Yes, sir.
Now tell me, what is the
Yes,
equation
sir.
of this? Hey, come on. What is the equation of this line?
Sir, I see equal to minus V naught by R and e to the power minus t by RC.
Good.
Okay, Jonathan,
Let us
just
see.
tell me what is the equation? E to the
E to
power
the
minus
power minus t by RC.
RC. Good.
Okay, Tanima, this is the answer you told me, right?
Yes, sir.
Now you tell me if you want to get 0.1 mark. This is positive V naught, but this is IC is negative, right? At time t equal to 0.
Yes, sir.
Can you explain why the capacitor current is negative at t equal to 0?
Sir, sir, cause it's in the minus, but in the negative side, that's why.
Okay. What? In the negative side means?
Minus, it's V minus
Okay,
V naught
it's
by
all right.
R.
Okay,
That's
I got a point. Okay. Maria Rahman, are you there?
Yes, sir.
Can you explain why?
Sir,
At time t equal to 0 is a negative current. Huh?
sir, the direction of the current is flowing in the negative, the opposite direction.
At what time the direction is changing?
Sir, at time 0.
At time 0, when the direction is changing, capacitor is what? Hey, Maria, you have to answer only. If somebody else answer, you get negative mark.
Yes, sir. Rakib, sir. Sir, Ami, sir.
No. Only Maria should answer. Maria, you give up or
Okay.
you can answer.
No,
When
sir,
when the current is flowing opposite direction, then capacitor at that time capacitor status is what? What the capacitor doing at that time? Maria.
Sir, capacitor is decreased slowly, sir.
Decrease slowly. What does it mean by decrease slowly? As an engineering student, you cannot answer this way.
Sir, can I?
Capacitor is decreasing physically. Physically, it is becoming smaller. the capacitor physically is is physically going to become smaller. Is it like that?
Sir, keep up.
Okay, I understand it. Now, next question to Nusaiba.
Yes, sir.
Nusaiba, there.
Yes, sir. Can
What
you
do
hear
think?
me?
What is the answer? Yeah, go ahead. Can you answer the question?
Capacitor is discharging.
Right, Maria. This is the answer. As a technical person, you have to
Oh,
answer
sir,
this
I
way.
say decreasing. Sir.
Decreasing means what? The size of the capacitor. The physically the capacitor size is decreasing to smaller.
Sir, before
Okay.
the lecture, you said that all the charge will be decreasing by the capacitor. Voltage of the capacitor will be discharging. Sir, এটা তো স্যার একটু আগেই স্যার পড়ানোর আগেই বলছেন।
And that one you cannot answer, right?
না স্যার আমি স্যার পারতাম স্যার হাত তুলেছিলাম স্যার।
No, but
Rakib.
just when your turn come, you'll get the one. Okay, now Nusaiba, now tell me, when the capacitor T is what time the capacitor was charging? T is more than 0 or T is less than 0?
Less
Nusaiba.
than, sir.
Nusaiba,
Yes, sir.
what is the answer? Capacitor is charging at what time? T is less than 0 or T is more than 0?
Less than 0.
T is less than 0, capacitor was charging. and at time t equal to 0, switch is open and starts
To
discharging.
discharge.
So the capacitor, when at t equal to 0, it starts discharging, that time the current is flowing in opposite direction, because charging current when capacitor is, the current is into the capacitor, and discharging current is the opposite direction, outside from the capacitor. That's why the negative at time t equal to 0, the IC current is negative, because at that time it is in opposite direction, because it's a discharging at that time. So this is the explanation for this thing. I hope that all of you understand. Thank you, Nusaiba. Go ahead.
Here, remember, this value will come as we have done for the last time for the RL circuit. So it is the same thing happening here, 5 tau, like that. And this tau.
Okay, here, let plus people, you try to get my point here. You okay, what's his name? What's her name? Nusaiba. Nusaiba got 0.1. Okay, now let's come back to the next one. Marufa, are you there?
Yes, sir.
Okay, what do you think about this tau? What is tau actually? What is the name?
So time constant.
Time constant for the capacitor. I discussed with the time constant for the RL circuit last time. Now I said the time constant, if you find for the RC circuit, you get time constant equal to RC. Can you remember for RL circuit, what was the time constant?
Yes, sir.
Yes,
R by L.
R by L, right. Now, if you want to find the time constant tau equal to RC, then what do you have to do? You have to find the derivative of the VC, and this one you get from here, the derivative. And also you have to get another slope, that is the slope derivative at this decreasing point. Another slope, you know, the linear slope, 2 points you have to find, and from the 2 points you have to find another slope, and 1 point will be coming here, another point will be coming here. These things, right? This is 1 point, and there is another point here. Now, what's your name? Marufa. Marufa, tell me this point, what's the value of this point? Give faster.
0 V naught.
0 V naught. Good. And what will be the this point?
So tau 0.
0. Now, if I ask you what is the slope, then tell me the slope equation from here.
So 0 minus V naught.
Then
Tau minus 0.
tau minus 0. Good. This will be equal to the slope you are going to get at this point. At this point, as I told you earlier, the slope is ddt of what? Can you tell me?
So the equation VCT.
VCT. Good. It will be dt, and this will be the slope at that point. And if you put the VCT here into this equation, you get the derivative. What is the derivative? Can you tell me? Okay,
Yes,
you
sir.
cannot tell me. Then okay. What?
Sir, it will be 1 by RC into V naught, then
Good.
e to the power minus t by RC.
So you said V naught by RC, right?
Yes, sir.
And e to the power minus t by RC.
Yes, sir.
Okay. You cannot get the marks because you make a mistake. Check it again. Is it correct?
So
Take the
there's a
deriv-
minus.
Then you have to tell that, otherwise whole thing will go into vain. Okay, if it is minus, this is the slope at time t equal to what?
0.
0. And you put t equal to 0 here, then you get what?
So minus V
Simply
naught by RC.
Yeah, simply minus V0 by RC. Good. So this will be equal to nothing but minus V0 by RC, right?
Yes, sir.
Okay, and then V0 cancel, then RC will be equal to tau. Understand it now?
Yes, sir.
So that's the way we can get the tau equal to RC for the terminal, and to have 2, 3, 4 like that, and then you can go for at what is the value of tau, 2 tau, 3 tau. Like last time, you can see up to 5 tau. So you don't need to go for it. I think you are absolutely correct, and you get 0.1. You deserve it. Thank you very much, Nusaiba. I'm sorry, what is the Marufa? You are very much clear about it, Marwa. Thank you very much for that. Now let's go for the next step.
How equal to RC in this case. Dr. RL, all of you can just draw it. You have to find the for the capacitor voltage, which is VCT, and plot it. At time t equal to 0, the switching action is at time t equal to 0, switch is going to be open. So what will be the VC nature, and find VC and IC and sketch them. This is a problem on natural response. Natural response. Remember, no fixed response, because why natural response? If you look at the uh, circuit switching action, at time t equal to 0, the battery is taken out. If the battery is taken away, then the remaining circuit is nothing but a RC circuit. Resistance and capacitance are there. So it will be a free running RC circuit, and you can easily apply the equation and can find the solution. Now you look, all what you have to do, as today you have also seen, and Jihad also told, sir, first thing first we have to do is we have to draw the two circuits.
Okay, live class, people, you understand it, what I mean now? Shahrukh Islam, are you there?
Yes, sir.
What is the first step if you want to solve this type of problem in the exam?
Sir, to draw first, t is less than 0 and t is greater than 0.
Beautiful.
Circuit for t is less than 0.
Absolutely, absolutely. That's your first step. You have to do t is less than 0, t is more than 0. T is less than 0 means the switch is what? Open or closed?
Sir, for t is less than 0, it was, sir, closed, sir.
It was closed.
Yes,
The
sir.
circuit will be like it is closed and the whole thing. I mean, all the things are there in the circuit. T is less than 0.
Yes.
This 2 ohm, this battery, this 4 ohm, this capacitor, all are present, and connection will be here connected like that. This is t is less than 0. And t is more than 0, so a switch will be
Sir, open, sir.
open. In that time, 9 volt will be disappear, right?
Yes.
Okay.
Yes, sir.
Okay, what are the thing remain?
Sir, the circuit from the, sir, if it is open, 9 volt will be, sir, will be not be there, sir.
Other than that, 2 ohm,
Other than
4
that,
ohm,
everything
and
is will be open. Yes,
capacitor
sir.
will be there. This is t more than 0, right?
Yes, sir.
So we are getting a free running RC circuit at what condition? T is less than 0 or t is more than 0?
Sir, greater than 0.
Greater than 0. Good. Now, if you go, then this is the one. T is more than 0. We are getting a free running RC circuit, and this is the t is less than 0. This circuit is required for what? Shahrukh,
Sir? Yes,
what
sir.
is the reason? What is the use of this circuit?
Sir,
This
because of free running RC circuit, sir.
No, it is the free running RC circuit. We can find the value. Okay, in the free running RC circuit, what will be VC equation?
Sir, VC equation will be, sir, V minus V naught by R e to the power minus T by RC, sir.
Right. So that is the VC equation. You know that, right? So
Yes, sir.
V naught by, this is the one, actually the V naught by V naught e to the power minus 1 by RC. So you got it, V naught by 1 by RC. Now my question is here, what will be the value of RC, R equivalent? R is what?
Sir, R is the R, here R is in series, so sir 2 plus 4 will be added, so it will be 6, sir.
6 and capacity.
R equivalent equals to 6, and the C capacitance equivalent will be, sir, 10 microfarad. So 10 into 10, 10 to the power 6, sir. So 10
Okay,
into
so
10 to the power 6.
you're saying this is 6 and this is, tell me
10
what
to
is
the
that?
power 6.
10 to the power 6, that's it.
Minus 6, sir. Is it
No,
micro?
no. Okay, minus 6, but I'm just talking about
No, sir. Here 10 into 10 to the power minus 6,
right,
sir. Because
that is
10
what you tell me.
microfarad.
What are you talking then? Okay, 10 into 10 to the power minus 6. Okay, if you get it, you have a calculator, you tell me if you want to find the value of this whole thing, this thing, put a 1 here, right? 1t. 1 divided by this thing. Then what are you going to get altogether over here? V naught into, can you tell me the using your
Yes, sir.
calculator, what will be this thing minus what into t? So what will be in the bracket?
So
To
the
simplify it.
answer will be, yes, sir. The answer will be, sir, V naught e to the power minus 1606 and 66. Altogether 1 into 46, sir.
1 into
46, sir. 1146. মানে
Okay, I'm writing.
16,666, sir.
Okay, if I write like this, can you tell me 1 point?
Yeah, we can.
No,
Yes,
let's
sir.
say 1.67 into 10 to the power what? Tell me.
Sir, sir, 10 to the power 5, sir.
10 to the power 5.
No, sir, 6. Sorry, sir.
6.
Yes. Sir.
Okay, all of you agree with him. He said 6.
1.6 into 24.
Sir,
No,
minus
sir.
1.67 into
Sir.
10 to the power 4.
4.
4. Sorry, sir. Sorry.
Yes, sir. 4.
Okay, it is 4. Don't
Sorry.
follow the lecture. Lecture slide, the lecture video is not correct. But
Yes, sir.
you have to find it. That is the reason why I didn't change. So you should tell me your answer, not from the lecture video. So if you tell me from your answer, it is 10 to the power 4.
4, sir.
Yeah, Shahrukh,
Yes,
you
sir.
understand?
Yes, sir. Yes, sir.
Now you tell me where the V naught will come from.
Sir, V naught will be count from less than 0, sir. T is less
Right,
than 0.
from you call it initial condition.
Initial
That
condition.
means it is giving you from the initial condition is coming from here, less than 0. Right, that is what
Yes, sir.
you get the initial condition, and you also told me.
স্যার স্যার লেফট হ্যান্ড সাইডের এটাকে যদি ইনিশিয়াল কন্ডিশন বলে তাহলে স্যার রাইট এরটা কি কন্ডিশন হবে স্যার? রাইট ইজ গ্রেটার দেন 0, এটা কি কন্ডিশন বলা যায় স্যার?
No, this is the circuit after the switching action. You got my point?
Yes, sir.
Okay.
Yes, sir.
This is
After the switching,
yeah,
yes.
that is what we are going to analyze. And after the switching
Oh.
action, the circuit is a free running RC circuit. And for
RC
the free
circuit,
running
yes.
RC circuit, we are going to find the voltage. And we found for the free running RC circuit today at the beginning, we saw this is the equation. And from there, we found up to this. Now, all are done except this part. Now, this is V naught. V naught is what? Is the voltage at the time of switching action. And that one will
Switching.
come from this condition because before switching action, what was the circuit condition? Actually, that will be the initial value and which will be nothing but V naught, right?
Yes, sir.
So that's why this gives you the V naught value. So if you want to find the V naught value from here, Shahrukh Khan.
Yes, sir.
Shahrukh Islam. Now you tell me from here, if you want to find the VC initial condition, initial value, T is less than 0 for long time, right? T is less than 0 means for long time, the circuit was like this. That means a battery 9 volt was connected to the capacitor for a long time, right?
Yes, sir.
So what will be the condition of the capacitor in that case? In case of inductor, you know what happened. If a inductor is connected for long time, what happened?
Sir, it will short, sir.
Short circuit. Now, in case of capacitor, what is the explanation? What do you think?
Say in case of capacitor, sir, the circuit will be open, sir. The capacitor will
Okay,
be open.
fine. You are because that one is short circuit, so it will be open circuit. But can you tell me how? The impedance for capacitor is what? X equal to?
Sir, X equals to sir 1 by omega c, sir.
Omega is what?
Sir, 2 pi f, sir.
2 pi f. So you can say 2 pi
Frequency
f
equals to
c.
0, sir. Yeah.
Yeah.
Yes, sir.
Frequency is 0. If frequency is 0, then what will be this? 1 by 0, right?
Yes, sir. That means, sir, infinity, sir.
Infinity ohm. So infinity ohm means
Sir, it will be open, sir.
open circuit. Infinity ohm means open circuit. So if you think this is open circuit, that means the capacitor is open means it is taken off. If you think long time this capacitor is open circuit means it is taken off, and the voltage at this point will be the open circuit voltage. So
Yes, sir.
this is VOC, open circuit voltage. It is open circuit voltage. You can easily tell me the value because you have done the Thevenin theorem, right? Thevenin theorem
Yes.
said the open circuit. What is that?
Sir, straight away 9, sir. Value.
Straight away 9 volt. Good. So you are getting here, it is 9 volt. If it is 9 volt, open circuit, it is 9 volt. What is the voltage drop here across the 4 ohm? This 9
So
volt is
zero.
straight on 0 volt, right? So straight away the 9 volt is coming across this two terminal. Exactly the same thing what you have done in V Thevenin. So Thevenin voltage is 9 volt, open circuit voltage is 9. So initially the capacitor was charged at V naught, which was 9 volt. So this is your open circuit voltage. A long time this capacitor was open circuit, and that long time the voltage at this terminal is 9 volt. That means VC is 9 volt for long time, and it is open circuit means it is fully charged. It is fully charged means there is no more current flow to charge anymore because it's already full. That means no current flow, no more charge, no current flow. That means open circuit, like the physical meaning. Okay, if it is open circuit voltage is 9 volt V naught, then you have to put the value. What will be the VC equation coming, Shahrukh? Your last question.
Sir, sir, it will be, sir, 9 into e to the power minus 1.67 into 10 to the power 40.
67 into 10 to the power minus 40.
Yes, sir.
That is now minus 40, right?
No, sir. Year 4.
Only
Plus
40. Okay, plus 40. So this is your final VC equation. Good. So that is what we can see. That means that V naught value you put 9. This 9 you can put here, over here, and you get the VC equation, which is like this, or this is like VC. Good. I think Shahrukh, you get 0.1 marks. Thank you very much for your good answer. And we can see that now.
Is 6.
6 into 10, or not 6 into, come up here, the omega here. As what should be the voltage here? It is less than, oh no.
Okay. Now Shahrukh got 0.1. Live class. I'm talking to Mohammed Shibli Noman. Are you there, Shibli? Shibli is absent. Now next question to Iftihaz Kabir. Mohammed Iftihaz Kabir. Are you there, Iftihaz? Iftihaz Kabir is absent. Okay, now next, Maria, I think I asked you a question, right?
Yes, sir, but I didn't answer.
No, but you could not answer the question.
Yes, sir.
Okay, can you answer this question? Just let me know. As Shahrukh told that VC0 equal to the equation, 9 into e to the power minus 1.67, 10 to the power 5t. Is it correct, Maria?
Yes, sir, no, it's 5, sir. 10 to the power 5.
It is 5 already there. Is it correct?
No, sir, it's 4, sir.
Okay,
9.
it is 4 here. Okay, now let's come back to the point. You tell me, I want to draw the VC equation. This is in this, we want to draw the VC curve from this equation. So we need two things. One, it is your VC0 equal to what? Another one is VC infinity what? Maria, if you make a mistake, first time you have to answer once only. Make a mistake, I will not give you the marks.
No, sir.
Now,
Sir,
yeah, just listen. Tell me what is the value here? VC0.
Sir, it's VC0 9, sir, 9 volt.
Just okay, 9 volt. And what is VC infinity?
0 volt, sir.
Right. So you are going to draw from 9 here and 0 here. So it will go like that.
No, sir.
Then
Go like upward, like decrease, sir.
what is the way it is decreasing?
Sir, it's graph. Sir, initially decreasing.
Now what is this one?
Sir, kunta 9. Sir, 9 into the
E, right? E is what? E?
E is equal to, sir.
Oh, come on. What is the name of E?
Sir, sir, আমি ভুলে গিয়েছি আল্লাহ কি হলো স্যার
Okay.
exponential
Right.
ভুলে গেছি
So you should say that the VC from 9 volt, it is exponentially decreasing to 0. This is the way an engineering student should talk. Not like that, I forgot it. Okay, now let's come here. Last question. Cannot answer, no marks. What is the equation of this line?
Sir, 9 into e to the power minus 1.6 into 10 to the power 40.
Okay, fine. So this is the VC equation. VC equation is this. This will be the equation for this one. Okay, thank you very much. I think that's all for your question. Now let's go to the video and let us have.
Sorry, sir. What is our the
This is what the VC equation, a VC curve you got. And last,
Yes.
how to
Sir.
find IC? IC equal to what?
Okay, now it is the open question. I already asked everybody, so everybody got marks, and Maria also got 0.1. I think it's done. Now everybody should raise your hand if you can answer to the question. How to draw the IC? Raise your hand. Okay, this is Nusaiba. Nusaiba, can you answer?
Yes, sir.
Go
We
ahead.
have to
What do you mean?
differentiate dVC by dt.
Okay, on the left hand side, what will be the current? T is
As in
less than
graph.
0. T is less than 0.
Achha, t less than 0, 0.
How you say? IC equal to what?
IC equals to C into d by dt of 9. That is a constant, so it's 0.
Good, excellent, beautiful. ddt of IC is 9 here. VC, so you have to put here 9. And if you put 9, 9 is a constant. So derivative of a constant is 0. That's why the current IC is 0. Right, now you tell me, Nusaiba, what is the equation of IC should be written? Is it
For t greater than 0.
Yeah, equal to less than 0.
T IC equals 0.
Beautiful. This is equal to 0 is the equation for that. Excellent. Now, Nusaiba, come here to get the 0.1 marks fully. On the right hand side, you have to find the IC equation for t is more than 0, right?
Yes.
What is that?
Do I directly tell the equation?
Yes, you have to tell me the equation.
Minus 1.503.
Now, equation is what? C?
Oh, C into d by dt of 9 e to the power minus
Right,
1.
good, excellent. D by dt of VC, VC means this guy. So you have to put the whole thing 9 e to the power minus 1.67 into 10 to the power minus
10
what?
to the power 40,
10 to
not
the power,
minus.
okay, 10 to the power 40, good. So if you take the derivative and do all the dark thing, finally what do you get?
Minus 1.503.
Minus 1.503, then?
E to the power minus 1.6.
It is 1.5.
Minus 1.5.
Yeah, minus 1.5.
Minus 1.503, yeah.
Okay, and e to the power minus 4.
Minus 1.67 to the power
40. Okay, good. Okay. If anything wrong, please tell me. Anybody got any error in her calculation? Now, Nusaiba. Is it Nusaiba?
Yes, sir.
Who's that talking to me? Nusaiba, is it?
Yes, sir.
Okay. Nusaiba, tell me now, if you want to go, you have to find two things. T equal to 0, what is the value? T equal to infinity, what is it, in order to plot it, right?
Yes, sir. For
Tell
t
me, what are
equals
the
to
values? T equal to 0, what?
minus 1.503.
Okay, I see 0 and I see infinity. So you said that equal to 0, it is minus 1.5. And what about infinity?
Infinity, I say 0.
I see infinity is 0. So at the starting, it is minus 1.5. It is minus 1.5. And at infinity, it is going to 0 means here. So it will go how? How it will go to 0? How? This way.
No, sir.
Then?
Exponential increase.
Right, exponentially it will dying to 0. So this is the equation IC. What will be the equation of IC here of this line?
Minus 1.503 e to the power
Yeah,
minus
good.
1.67.
1.64. So this is your IC equation as you have already calculated, and this equation will be coming here. And that is the IC equation for this line. And Why it is minus 1.5? We don't need to mention again because all of you understand it. No, Saiba, right?
Yes, sir.
Negative current. Why? Tell me.
Because capacitor discharged it.
Good. Okay, thank you very much. So you all understand the solution to this problem. How
Sir,
to, yes, sir.
স্যার স্যার
Anybody?
মনিরুন অনেকক্ষণ ধরে ঢোকার ট্রাই করছে, ওর কারেন্ট চলে গেছিল, এর জন্য বের হয়ে গেছে। একটু
Okay,
কি ঢোকানো
ask.
যাবে?
Yeah, no. Ask you what he asked him to give me a call at my emergency number, right?
ওকে ওকে
He forgot about my emergency number. Just shoot him. Several times I told this thing. This is what you have to do. Any problem, emergency, no disturb other students in the classroom. Ask me, straight away call me. Okay, now let's come back to the point. This is what Monira, I'm sorry, Nusaiba, excellent way she answered the question and everybody understood it. Good.
Sir, less than 0 is equal to 0, sir.
Yeah, how you got that one we need to know. Right here. I see this one and we will solve. Everybody understood it. And next class we are going.
Okay, now all of you got the solution and understood how to solve the natural response problem. And we are going to jump to the next what do you call that, next part of the RC circuit, that is complete response for the RC circuit. Now we are going to go like the RL circuit, as you have seen, the complete response. Okay, like that way we are going to go now. The complete response of RC circuit. Okay, can you see the screen? Hey,
No, sir.
Yeah, so I think all of you can see the screen now. Can you now see? Oh, I'm sorry, I didn't share it. Okay, I'm sorry. Can you see now?
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
This is the complete response of the RC circuit we are going to see. Hey, who told me that one of your friend was trying to enter but cannot? Marufa? Maria?
No, sir. It's Tonima Appa.
Sir,
Okay, Tonima, did you inform him?
Tonima.
I got it. Tonima, did you inform him to call me?
Yes sir,
Okay.
yes sir,
Then it's
yes
all right.
sir, I informed her.
Okay, just he's not calling me. Maybe he needs to pay money for that. Is it something like that? Okay, now let's come here.
Sir, I don't know.
Okay, that's okay, no problem. I'm just telling you all, you have to raise your hand if you can answer to the question. The question is, the complete response of RC circuit will be equal to what? Like the RL circuit, you know, the complete response of RL circuit was what plus what? Like that, the complete response of RC circuit equal to what plus what? Yeah, Rakibul Islam raised hand. Rakibul, tell me.
Sir, natural response এবং force response এর যোগফল, sir,
Absolutely good.
is
Thank you
equal
very
to
much.
complete response.
Right, good. Thank you very much. So let us see.
Be what do you call
Thank you.
that, bonus marks as well. So everybody should be ready to give me answer as well. In order to do that, you need to let us the a RC circuit. So here it is. Now if we go for the circuit like exactly same type of circuit here as well, there's a switch here. The battery is going to be applied on a RC circuit. So this is your R. T equal to 0, the switch is closing so that a voltage source is imposing on the RC circuit. And in case of RC, we are going to see the effect on the voltage because the capacitor is accumulating the charge. So the voltage is increasing here, which we can say as a VCT. Last time for inductor, we considered the RL. And this time we are going to consider as a VC. So VC is the voltage across the capacitor going to increase or decrease with the current flow. That is what we know. So if this is the scenario, what does it mean? It means at time t equal to 0, switch is closed and a voltage source is applied or imposed on the RC circuit. So what will be the VC? That's the question. The VC we are going to find, since a voltage source is applied on it, so it will be having the complete response or not, which is a natural response and forced response. So if you go for that, your complete response will be straight away V natural response plus V forced response. Last class I told you forced response means for t tends to infinity. A natural response means free running RC circuit response. Free running RC circuit response. Okay, now this is the way you have to find. Then what is the next thing you have to go for is Vn. You already know Vn natural response is exactly the same. Last class I have shown you e to the power minus. Can you remember if it is
Yes,
RC,
sir.
free running RC circuit, what is the equation? It is yeah, it
Minus
is V
T
naught.
by
Instead of V naught, I'm writing here A.
A
Yeah,
and
by
T by RC.
RC. This is the time constant RC, but I didn't show you constant, told you to understand by yourself. And VF. Now, open, I mean the classroom, live classroom people, the force response for time t tends to infinity, we are going to find here. Raise your hand who can answer to this question. Force response will be what? Okay, Rocky will already answer. Now Marufa Akhtar. Marufa, what is the answer?
So V equals to IR.
I'm asking you, VF equal to what? What is equal to what? VF.
So VF equals to IR, Ruben?
IR.
Yes, sir.
IR means what?
So current into resistance.
So where is the current you find here? Because we are all talking about the voltage only, right? So first thing is, Marufa, you tell me, for t tends to infinity, what the capacitor will be?
So open circuit.
Open, good. So if the capacitor is open, then VF means the voltage across, this is what the capacitor voltage. VF is a for t tends to infinity. What is the capacitor voltage? Is the VF. So t tends to infinity, this is an open circuit. Open circuit means what is the voltage at this open terminal? If it is open circuit, what is the voltage?
Equal to the supply voltage.
What is that?
E.
Right. So you should tell me only E. IR you should not say. Where is I?
Sir.
I is not there. So E is because it's a close. For long time switch is off, switch is on, and this E is coming here directly here because this voltage is 0 voltage here. So rest of the voltage E will be coming, battery voltage straight away coming to the terminal A and B. A and B will get the battery voltage E. So VF will be nothing but E, right?
Yes, sir.
So VF is nothing but E because for long time, T tends to infinity means for long time, capacitor is open circuit. Open circuit means the open circuit, this is open terminal. So open circuit voltage. Open circuit voltage, the E is coming here as an open circuit voltage. Yeah, that will be the voltage you should get for VF. Marufa, clear?
Yes, sir.
Now you tell me the battery voltage E is known, the resistance R is known, equivalent resistance, capacitor C is known, everything is known. Only the T should be the variable. Only one thing we don't know. What is that, Marufa?
A.
A. A comes from where? A comes from the sky.
No, sir.
Initial condition. Good. Now, initial condition means at time t equal to what? Initial condition comes from where?
0.
0. That's a t is 0. Before t is 0, at t is less than 0, it was what? That will be the initial condition. But t is less than 0, the circuit was what? This switch was?
So open.
Open. If this switch was open, then what was the voltage across the capacitor?
So E.
Now, how come? Because this is open now, isn't it?
Yes, sir.
If it is open, then E is out, right? The open is what? The
Yes,
battery
sir.
is taken off, right?
So then VC.
VC will be what? That's what I'm asking you. VC. At that time, VC equal to, that means at time t equal to 0. What is the VC? That's my point. Alpha, you understand my point?
Yes, sir. But I don't know the question.
Yes,
I
you
don't
don't know the
answer.
answer because there is no current flow, right? Through the capacitor.
Yes, sir.
So no charge accumulation. So initially, if it is a fresh capacitor, there was no charge at the beginning. That means what? Voltage will be
0.
right. That is the case. So straight away at time t equal to 0, if there is no charge inside, since there will be no current flow, so the voltage initially it was 0. But if somebody already inserted some charge, then there will be some voltage there. Then maybe it's a 5 volt. So you can write here 5 volt at time t equal to 0 because initially there was some voltage in the capacitor. There was some charge in the capacitor, and that's why if there is a charge in the capacitor, static charge, and you connect your multimeter, measure the voltage, you can get the voltage. You'll get some voltage for that charge. But if you assume it's a fresh capacitor, there is no charge inside. So before the switch is closed, no current flow. So initially, if there is some charge, then there will be some voltage. If there is no charge, there will be no voltage. But here in this problem, we did not give you any charge inside the battery. Nothing told means you assume there is no charge. That means the voltage was 0 initially. Marufa, you got it?
Yes, sir.
Now, at time t equal to 0, what will be Vp? This is, what is this? This is Vct equal to, the equation is this, right, Marufa?
Yes, sir.
Now, in this equation, if you put at time t equal to 0, then Vc0 will be equal to what? Marufa, go
So
ahead.
A plus E.
A plus E, because what will be this thing?
1.
1, good. So A into 1, I'm writing initially, that will be better. Into E. Can you tell me A equal to what?
Minus E.
What is this value?
0.
0. Here we go. It is 0. So if you put 0, A equal to minus E. Excellent. Beautiful. That's the answer. A equal to minus E. Now this A value, you have to substitute over here in the main equation. Where? Here. Okay, you got the A as you told me earlier. We'll get the A from the initial condition. We got the A from the initial condition. What is that? That is A equal to minus E. Now you have to substitute the A here and you get a VC equation. That is our final equation of VC. Marufa, last question. You tell me, you go back home. What is that? VCT equal to what? After
So
substituting.
minus A minus E to the power minus T by RC plus E.
Right. And if I take E from here as a common, then what will be the value inside the bracket? Tell me.
So 1 minus E to the power minus T by RC.
Beautiful. Good. So your job done. Minus T by RC. So I hope that all of you understand what Marufa said. This is our final equation after substituting the value of A, which we got from the initial condition. Everybody understood how to apply the initial condition into the circuit, and you found the value of A. So Marufa got 0.1. Thank you very much, Marufa, for your answer to the question. I hope everybody understood it. If any question, you can tell me. Now, Marufa, what is your serial number? Marufa. Okay, you have C2. I think you got 0.2. All right. Thank you very much. Next, we can go ahead.
VF voltage axis, it E voltage is a value is of C. Now
you
at
already
time
understand.
T equal to 0,
You already understand this thing. Marufa already explained.
so the switch was open, right? It was open before the switch is closing. That means it was open. It is closed at T equal to 0, but before that switch was open. If the switch is open, then at that time, what is the voltage across the capacitor? That means when you connect the circuit on the breadboard, you go to the LTO and ask the LTO, give me a capacitor, give me a resistor, and give me a battery. Then you connect like this. And before you switching, if you close your, before you close the switch, hey, try to get my point. You in your lab, if you go to the LTO and ask him, give me a resistor, give me a capacitor, give me a battery, and a switch. This 4 item, and then with the wire you connect it. But before you on the switch, you measure the voltage across the capacitor by the multimeter. What will be the voltage? It will be the voltage when you connect, when you collect the capacitor from the LTO. At that time, what was the charge inside the capacitor? That charge will give you the static voltage. If the capacitor, the LTO gives you which is having no charge in it, all the charge discharged, a empty capacitor, then what will be the voltage across the capacitor? Hey, if there is zero, if there is no charge in the capacitor, there will be no voltage, because charge, more and more charge, voltage is increasing. It's a proportional. If a charge is zero, voltage is zero. So we assume you get a fresh capacitor to do this project. So if you get a fresh capacitor means there is no charge inside the capacitor. But if there is charge in the capacitor, then you have to put that value here. But if assume that there is, if not given in the exam initial condition, then you have to assume that you got a fresh capacitor. What does it mean? It means the voltage is zero here. That means at time t equal to 0, the VC0 is 0. At time t equal to 0, the voltage across the capacitor is assumed 0 because it is a fresh capacitor. Full stop. If you understand it, then we are going to substitute that condition now. So at time t equal to 0, VC0, so VC0 means this is 0, and this is coming here as A into e to the power 0 is 1 plus E. Okay, now at time t equal to 0, VC0 is 0. We are going to assuming. So if it is 0, what will be the value of A?
Minus E.
Right, A plus E. So A is going to be minus E. If A equal to minus E, now you can substitute this A value into this equation and get the VC equation like this. The VC equation will be coming here straight away like this, which will be E1 minus e to the power minus T by RC. This is what, after substituting the value of A, you are getting the equation for VC like this. This is your complete response equation. Now we are going to plot it in the next page. If you go here, then you can see VCT 1 minus e to the power minus T by RC. T by RC. Okay, now if you go with the plotting case, okay, at time t equal to 0, VC 0 and VC equal to what? Can you tell me? At
Sir, we cannot hear you, sir.
Okay. Okay, I'm sorry, but some dark already. Okay, now let's come back. You have to raise your hand if you can answer. VC equal to 0, VC equal to infinity equal to what? You have to write it and then we have to draw it. Raise your hand. Okay, Maria Rahman.
Yes, sir.
Yeah, Maria, I'm sorry, Nusaiba was there, right? Okay, Maria, can you tell me what will be VC0?
The VC0 equal to E.
What?
E, sir.
B or E?
E, sir.
Okay, okay, good. You said VC0 will be equal to E. Now, hey, listen, come on, don't talk. Somebody is talking or what? Okay, now next, Rakibul Islam. Rakibul, what is your answer?
Sir, 0, sir.
Not E, it is 0.
Sir, 1 minus 1 equal 1 minus 1 equal 0 0 গুণন E equal to sir 0 হয় sir.
So 0. Now Rakibul
Yes.
Islam, tell me then VC infinity equal to what?
Sir, VC infinity. Sir, infinity is equal to sir. Wait sir. Sir, E হবে sir.
E.
E, yes sir.
Okay, good.
Yes sir, E sir.
Okay, thank you very much for your answer. You can shut down and we can see the answer is correct or not. Let us go. Okay.
Time t equal to 0.
0 sir.
At time t, I'm just writing here, time t equal to 0, t equal to infinity. So t equal to 0, VC 0 is, you said 0. All of you try to get it. At infinity, what is that?
E sir.
Then infinity, it will be E. Good. This is the thing. Now, if you plot it, VC versus t, plotting is very important to understand. This is 0 and t is less than 0, t is more than 0, for example. So t is less than 0, the
Okay, drop your hand, all of you. Now tell me, t is less than 0. You have to tell me the plotting. Raise your hand. Who can tell me t is less than 0? What is the voltage? Okay, who answered the question last time? Rakibul Islam, right?
Sir, Rakib, yes sir, yes sir.
Just a minute. Rakib, your serial number is what?
Sir, 9 sir,
Okay,
serial
yeah,
number
that's
9.
okay. Okay, good. Thank you. Now let's come back to the next people who are Munirun Nessa. Munirun Nessa, tell me, t is less than 0. What is the VC?
Sir, it will be, sir, straight away with the line t less than 0.
Yeah, it will be what? Clearly tell me, what is that?
Sir, it will be, sir, it will,
Like this.
yes, sir.
What is the value?
Sir, the value is 0.
This is 0. Duck. If it is 0,
No,
then
sir.
is it 0 line? Is it 0 line? Is it 0 line, Munirun Nessa?
No, sir, I told that the light will be, yeah, sir, t less than 0, it will be in that line.
Okay, that means this one.
Yes, sir.
Okay, then you should tell me that it will be 0 line. This is the 0 line,
Yes,
right?
sir.
Why you say this is 0 line? Okay, good. So at time t equal to 0, it is 0. So Monirun Nessa, I'll give you 0.1 marks if you can tell me the equation for this line. What is the equation for this line? VCT equal to what? E to the power what? E into e to the what? Can you tell me what will be the equation for this line? E into what? Or what is that? Can you tell me? Just tell me what is that?
Sir,
You are in trouble, right?
Sir,
No,
এটা
sir.
Hey, any boyfriend? Negative marks. Okay, Manu, submit faster. If you cannot answer, tell me no. I'm sorry.
No, sir, the practice in us.
Right, that's it. And that you are not getting the marks. Full stop. Shahrukh Islam, are you there?
Yes, sir.
Okay, you tell me what is the answer.
Sir, straight 0, sir.
Straight 0. Now let me because this 0 line is a 0. It's a 9. If it is let's say Monirun Nessa, if this is the value which is 3. Now if I ask you what is VC, what is this equation? Monirun Nessa, can you tell me what will be this value? VCT will be equal to what?
Sir, for t equals to 0.
No,
No,
this
sir,
line.
sir, it will be 3.
3. If it is 3, then why not? Why you cannot tell me this is what? This will be straight away 0, right? Isn't it?
Yes, sir.
So why you could not answer?
Confused.
Okay, careful about it. Next time you can answer, I hope. Now, Shahrukh, your marks not yet given.
Yes.
Because you have to answer some more. Now, at time t equal to 0, what is VC?
Sir, at time t equals 0. Sir, VC was 0, sir, at that time.
Switch is closed. At that time, what will be the VC?
Yes, sir.
0.
Sir, VC is equal to 0, sir, at that time.
0.
Yes,
At
sir.
time t tends to infinity, what is that?
Sir, exponentially, sir, it will be increase. So the curve will be up like 0 to,
Up
sir,
to what?
up to E, sir. Up to
E to E. So let's say this is your E. If you say this is
Yes,
E,
sir.
yeah, and I can draw it to there. different pen that E is there. It is the dotted line for E margin coming. Okay, like this. This is E value. I'm talking about this is E. Now
Yes.
this curve will go up to E, you said. That means it's go to E like this, right?
Exponentially. Yes. No, sir. No, sir.
Then how?
It will go, sir, upward, sir. Like it will
Exponential. It's called
increase, sir.
exponentially. It will
Exponentially, yes, sir.
exponentially increase to
Exponentially,
that.
yes,
We
sir.
call it like that. So it is just yeah, don't misunderstand. This is exponential curve. So it will go exponentially to E and merge with E, the final value at infinity time.
Yes,
It
yes.
goes to E. And it's a zero, it is zero. So this is the curve you can see from here to here. Now, Shahrukh, what is the equation of this duck?
Yes, sir.
Tell me.
So VCT equals to E into 1 minus e to the power minus t by RC, sir.
That means this is the equation, right?
This equation, yes, sir.
Okay, it will be following this equation for this line. It is equal to 0, and that will be VCT equal to that thing over here. As coming here, that's one equation for this. Good. Shahrukh will get 0.1. Now, next question to Shahrukh got the 0.1. That means you're getting 0.2 now. Okay, now all of you drop your hand first, then we have to ask question. Otherwise, okay. Now I think you can see the
Voltage
video.
is
Okay, this is
what is
the
it will
one
be
as
this switch on. Okay, 3 of the bonus point. Another IC current.
okay. Okay, this is what Shahrukh said, and all of you understood that VC equal to up to this, we have got the VC curve. Now, if we want to go for the IC curve, who can answer the IC how to draw? Raise your hand. Okay, first Nusaiba raised her hand. Okay, Nusaiba, tell me, you want to find the IC curve. What to do on the left hand side? If you go for from VC curve, okay, I'm sorry, I can draw it in a different pen. If you go for the, yeah, this curve, IC T versus IC, okay, and tell me on the left hand side, T is less than 0, Nusaiba, what to do?
It will be 0 as
How
differentiation
come? What
of
is the
0 is
equation? What is the equation I see?
C d by
Huh.
dt of 0.
Good. C d dt of what?
0.
What do you mean by 0? 0 comes from where?
So t less than 0 to VC was 0.
What is the equation? I is equal to C d
Oh,
dt of,
acha. C VC d by dt of VC.
right, d dt of VC. Then you put VC value here 0, right?
Yes, sir.
And if you put VC value 0 here, then you get the whole thing is 0, Nusaiba.
Yes, sir.
So follow the sequence, whatever you like, you cannot tell. Okay, now where is the equation comes from? I see line will be like this one, is it?
No, sir.
Then
Origin is 0.
okay, original 0. So the green line, it is the 0 line. Now you tell me, Nusaiba, what is the equation for IC here?
IC equals to 0.
IC equal to 0. ICT equal to 0. This is the equation of this line. T is less than 0. Good. Now, at time t equal to 0 and t is more than 0, it follows the equation. What will be that equation? I see.
C d by dt of E 1 minus e to the 1 minus e to the power minus t by r.
So you said C d dt of VC formula.
Yes.
And VC
Yes,
is what
sir.
here?
E
E.
1 minus.
No, E you multiply inside. Then what will be that?
Acha. E minus e
minus E
to the power
it will be
t by
what?
r. T by
Right,
r.
it will be minus T by RC. So that will be easier, right?
Yes.
In that case, it will be RC, and that will be the equation. Now, if you multiply E inside here, actually, that is the case we are talking about. E is there, minus E to the power E by RC, T by RC. Now you can take the derivative of this thing, and it will be finally what you are getting, Arufa. I'm sorry, Nusaiba.
E by r
Okay, this E will be what?
0.
Zero. But the derivative of it, yeah, good. Derivative of this constant will be 0. Good. And then you are getting what? Can you tell me? Ultimately, you are getting what?
E by R,
E by R. Okay. E by
e to the
R.
power,
E by R. E to the
e
power
to the power minus t by R.
minus T by RC. Okay. There C, where C gone?
Sir, when we differentiate
This C will be
e
missing.
to the power c ta kete
Yeah.
যায়.
CC cancel out. So you are getting like this. Excellent. Now, Musab, all of you understand that is IC equation. Musab, tell me now, IC equal to 0, IC equal to infinity. You want to draw it, you have to calculate it first. Can tell me
Yes.
what will be the value for IC equal to 0, IC equal to infinity? Go.
Ic equals to 0 would be e by R
Plus or minus?
plus
Plus. Good. So E by R. Then what about infinity?
0.
Infinity, you get 0. Good. So if you want to plot it at time t equal to 0, what will be the value?
E by R
Okay, so up or down?
up.
Good. So this is E by R, jumping up to E by R. So this is your E by R value at time t equal to 0, IC value. This is coming from here 0, this is coming jumping here, and then from E by R at time t tends to infinity, where it goes to?
It will exponentially decrease to 0.
0. 0 is here at infinity, 0 is here, you can imagine infinity, this is 0. So it will exponentially decreasing to 0 line, right? That is the way it goes to 0. Good. Musaba, this is the way you can get it. Now, last question. What is the equation of this duck?
Ic equals to e by R e to the power minus t by RC.
Beautiful. I see equal to E by R. This is E by R e to the power minus T by RC. E by RC, that is the equation you got over here, right? Musaba.
Yes, sir.
That is the equation you are getting here. Good. Excellent. And that's all about your what call that this thing, the explanation of E and IC, BC and IC. That's Anusara will get point 0.1. There's no doubt, but I'm just asking okay, all of you can have a look of first of all, you all look at it and then we'll go for it. Okay, let's go and see the video.
Differentiate or the in substitute this by RC, right?
Look how Nusaiba told what the values should be, and those things we have seen. Okay, Nusaiba got another point 1, it will be point 2 now. Okay, now look at it and see what happens.
Yes.
Okay, now e to the power IC0 is what? IC0 at time t. Now I am asking one who are not interested to answer. Just a minute. To the voltage is 0, but the current is maximum. That means voltage is 0 at what?
Okay, now the last question for today. You all ready to answer? Explain this thing. Actually, you have to explain this point and this point, this point, this point, and this point. Okay, can anybody explain these 2 points, which is A prime, the current and voltage, and this is B prime. I'm talking about, can you anybody explain this? What is the meaning of A prime and B prime? Can you explain these things? Raise your hand. Okay, Marufa Akhtar, good. Can you just answer, Marufa? What is the answer? Can you tell me?
So when the switch was closed, the capacitor started to charge, so voltage 0 chilo. আর because it didn't have any voltage, তো তখন কারেন্ট হচ্ছে পুরাটুকি ছিল, তো maximum, and then when it began to charge, তারপর আস্তে আস্তে voltage VC এরটা বাড়তে থাকলো আর রেজিস্টার across কমবে VC, কিন্তু পরে যখন ফুললি চার্জ হয়ে যায় তখন হচ্ছে এটা মানে সার্কিটটা রিজেম্বলস অ্যান ওপেন সার্কিট, তো আইসিও হচ্ছে 0 হয়ে যায়।
Okay, so you are saying BB prime and AA prime. I'm telling you AA prime and BB prime. What can we define this 2 point? AA prime is what type of, BB prime is what type of condition? BB prime is what?
স্যার ওপেন সার্কিট।
Beauty, excellent. I'll give you 1.2. This is open. Have you seen the video lecture before? No.
নো স্যার।
Beautiful. Are you telling me the truth?
Yes sir. Sir, I studied for the lab class.
Okay, good, good. Now, what is this one? What is this one then?
Sir, short circuit.
If it is open, then it is short. You understand it? It is short circuit, right?
Yes, sir.
Okay, good. Short circuit. Beautiful. Excellent. This is the excellent answer you have given. I'll give you 0.4, 0.2. Okay, because at short circuit condition, you know, voltage is 0. So when there is a short circuit, voltage is 0, right? All of you understand it. Please try to understand. There's a resistor. This is the thing, point, this 2 point. When there is a short circuit here, the voltage is V. This 2 point voltage is V. When these 2 points are shorted, you all know that when these 2 points are shorted, then V will be equal to 0. So at short circuit point, voltage is 0. Maximum current, what is that? Current is maximum I short circuit current. So at that time, the current is E by R is a maximum current flow. But at time t equal to 0, it is 0 volt, means short circuit. So at time when switch is time t is 0, to switch is just closed at time t equal to, at that moment, actually the voltage is 0 and current is maximum, and then it started flowing. Means you on the water tap in the bucket, a lot of water flowed, but pressure at that time is 0. That is the thing, is a short circuit starting point is a short circuit point. That is the thing here. At short circuit point, we know that the voltage is 0 and current is maximum. And it goes, the water is filled, the current is charging, the capacitor is full here. When the capacitor full long time, it is open circuit. As you know, all of you, that a long time it is going to be fully charged, open circuit. So the voltage is full as a VCC or 4E voltage for T equals to. At that infinity time, what happened? Current goes to 0. So open circuit case, what? Open circuit, there is no current. If you open the circuit, current flow 0. And but the voltage, open circuit voltage will be the battery voltage. So battery get the voltage maximum, but current is 0, which is nothing but the open circuit. And this is short circuit. Excellent explanation. Thank you very much, Marufa. Is it Marufa?
Yes,
Hey,
sir.
who answered? Okay. Thank you. Marufa will get 0.4 now altogether. Thank you very much. This is the correct answer. And thank you very, very much. Up to this, we are going to finish. And next class, we are going to talk about, I'm going to show you, but you can, maybe you cannot get it. I'm talking about this thing we understood. And next class, we are going to talk about the next question will be this card we are going to discuss in next class. And this will not be included in the CT4. Only CT4 will be included up before just this one, up to this. CT4 will be with the complete response theoretical part. But no problems will be coming from this part, that is a complete response for capacitor. So up to this will be our CT4 syllabus. And next class we'll solve the complete response problem for capacitor. I think that should be fine. Everybody understood what I mean.